This is the COVID lockdown update of my building of my large wheel skeleton clock by Mr. Welding, John Welding. This project has had a ridiculous time scale, and it's been going for 15 years. I haven't touched it for 5 years, and then I picked it up recently because there wasn't enough hours to fill in the day, and decided to just go for it and finish it. So here's some video of how I've been getting on.
This is cutting out the hands video. Hands are cut out of a 1mm thick piece of steel. Program. Here is the program. The CNC program loaded into the PC. This shows the hour hand being cut. It's called, in clockmaking terms, it's called the motion work. Exactly why it's called the motion work, I don't know. But I have to make a new mandrel to mill this piece out. Today's job is to make up a thing called the center arbor. That's this shaft here with a 16th part off in the lathe, the 3 screws that hold the wheel to the arbor, the arbor itself, and attach the pinion, which I didn't make because I don't have the tooling for it. But this pinion costs about £15. Here's a video of making a clock pinion. This is a rather noisy operation, but basically it uses a surface grinding technique in the vise. Very delicate operation. This jig here, fashioned out of a Black & Decker mini drill, is absolutely ideal for it. Now that all the gears and all the pinions are made, I've now got the problem of depthing the gears. Depthing the gears is all about getting them to mesh properly. This is a little jig which I made, and you can see that once the gears are meshed, they spin freely, and this is what you want them to do in the clock as well. This gauge had to be made because there isn't anything on the market that will do this job. Now that I've made all of the bits that turn, this is the escape wheel, this is the escape pinion, this is the escapement itself. This the bits are sitting in at the moment is called a depth gauge. A depth gauge usually looks like this. You put one gear in at one side, you put one gear in at the other, and you measure, you alter that until the gears mesh, and you transfer that onto your clock. The problem with this is that the gears are much bigger than normal, and the normal depth gauge doesn't work. So I've had to fabricate this depth gauge in order to cope with all the large wheels in this project. Here's a better example of the problems of the depth gauge for this particular clock. This very large wheel, it's about 12 inches in diameter, and it goes on to an 8-leaf pinion down in the corner here. And the problem is that you've got to gauge whether you've made the gear uniformly correct the whole way round, and also that when you put it in the clock and drill the holes for it to be located, you only get one chance at that. You've got to ensure that the distance between the center of the two cogs is exactly correct, and you've got to transfer that dimension onto the actual clock. You can't even afford to measure it. It's got to be transferred from the depth gauge to the clock. This final shot shows the depth gauge and all its parts. You've got this vernier adjustment here. You've got different heels that you can fit on for different types of gears on the clock. This is the one that I used for the two third wheels, and this is the mandrel I used for the 12-inch wheel. Final job now is to assemble the clock, very like this diagram. Here is the frame, here's the spring barrel, but you'll notice that the frame has got no holes in it. The holes have got to be precisely located, and that's why you need a depth gauge.